Okay, here we are, and I'm going to track the cosine curve this time. So I've drawn the unit circle. I put in the monkey math, the quadrangles, and I noticed the first coordinate at radians 0 is 1. So over here on my cosine curve, instead of starting at 0, 0 like the sine curve did, at 0 the cosine is 1. And we knew that from our chant, cosine 0, 1. All right, so let me put in the area, the value, the radian values that I'm going to track. So pi over 2, pi, 3 pi over 2, get out of the way, and then 2 pi. All right, so we've got 0, 1, and then the first coordinate, this time the cosine, comes down by pi over 2, it comes down to 0. So we got to track it on down to 0 value of 0 at pi over 2. Then the first coordinate goes even further down, so get out of the way. All right. This went up to 1, started at 1, is down to -1, so let me write the name of this curve, y equals cosine theta. So it's going to bottom out at pi radians. We see it's -1, so we come down to -1. Pi over 2, our first value goes back to 0, so at 3 pi over 2, we're back up here, and at 2 pi, this is the same as what happened at 0 radians, we're back at 1 again. So there's one cycle or period of the cosine curve. And this again doesn't stop there. It continues on in like manner in both directions. All right, so let's investigate the amplitude. The amplitude is going to be the distance again from the center line to the highest point. So what's the distance here? Or we can look at the distance here, or we can look at it here. All of those are the amplitude, and they are all amplitudes. They're the same, they're 1. What is the period? The period is going to be, and how many radians does the cosine function run through before it repeats itself? So let's start from here at 0 because it's the easiest place to count. When do we hit that peak again? So we go down, come back up, and bing, 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 right there. So how far is from here to there? 2 pi radians again. So the period for the cosine curve is 2 pi. So putting that into, so here's our cosine curve, which on demand you have to be able to reproduce that. So when I say give me a sine curve, you'll go up to 1, down to -1, you put in the tick marks like that. The sine curve, you know, will start here and go this way. And if I asked you to do the cosine curve, hopefully this other color will show up. You do the same setup, but you'll start here and go down through here and back up. So that's the cosine curve right there. So you'll have to be able to reproduce that on command. All right, we'll finish this discussion and look at a couple aspects of how we represent this in equations. So what we can do with equations when we represent these sine and cosine curves. So we started out with the basic sine curve, and I want to see what my timing is. All right. So on the on the sine curve, there is some information you need to know that I can alter about this basic sine curve. So I had mentioned to you the basic sine curve goes up to 1 and down to -1. But sometimes we run into a curve that has another piece of information, and it looks like this. Y equals 3 sine of theta. This number messes with the amplitude. So the amplitude, see if I can spell it this time. The amplitude is no longer, it's unwritten 1 up here because 1 times sine, so we don't write the 1, but everyone understands that the amplitude is 1 up in that example. But when the amplitude number, this is the position where we always find the amplitude, here it's raised to 3. So we're going to see that instead of, we're still going to have the same period, so we're going to have pi over 2, pi, 3 pi over 2, 2 pi. So instead of going up to 1, this sine curve right here is going to go up to 3 and down to minus 3. So up she goes, peaks up there, down through pi at zeros out here, bottoms down here at negative 3, and back up to where we started. So that's one period or cycle of y equals 3 sine of theta. And it goes on like that. So what would happen, do you suppose, if I asked you to graph y equals 2 cosine theta? All right, so being a terrific student, you would draw in the pi over 2 parameters, pi, 3 pi over 2, all the monkey math, and you will expect cosine as usual to start, you expected it to start at 1. Let me move 1 down on this graph so I have room. Say this is 1. And this is minus 1, but this has had an amplitude change, so instead of going up to 1 and down to a negative 1, it's going to go up to 2 and down to minus 2. So it's going to go up and down and up. And notice it does all that. That's a little crooked. It's supposed to be quite symmetrical. It's going to do all that within 2 pi radians, so that we haven't changed the period, just how high and how low it goes from the center line. So this goes up 2 and down minus 2, which we still call an amplitude of 2. All right. What do you suppose would happen if I had a negative 4? Let's do sine. We're flip-flop. Y equals negative 4 sine of theta. So what I've introduced here is a negative amplitude, where I just said amplitude is always positive. So I'm not really saying that it has a negative amplitude, but I am saying the sine curve is negative, and there's the negative sine curve has an amplitude of 4. So as you suspect, 4 is going to be involved on the vertical axis, so I'm going to go up to 4 and down to negative 4. But let's discuss what this negative sign in front does. So let me put in my terrific parameters here, as terrific students do. All right, so now we're going to go from 0, 0, we're going to, instead of going up, this negative sign will flip the sine curve. So it usually started at 0, 0 and goes up. It's going to go down and go like that and like that. So, and then it will continue and so forth. I don't mean to mention that it'll, or indicate that it'll stop at that point. All right, I'll do one more real quick. Let's do y equals negative 1/3 cosine. So why don't you stop and try that on your own and catch up with me after you think you've got it. So this is 1, this is minus 1, and pi over 2, pi, 3 pi over 2, 2 pi, and I'm going to start up. I would have started up here with a cosine curve normally, but I'm going to start down here, and not only am I going to start at negative 1, it's only going to go down to negative 1/3. So I'll put those in. So it's going to start here, then it's going to peak at pi, and it's going to go down at 3 pi over 2, and bottom out at 2 pi. So it's an upside down cosine curve with an amplitude of 1/3. All right, I have one more little discussion, so let me shut this part down and pick it up on our last terrific segment.